In this video, I'm going to go through the cosine rule. There's another video related to the sine rule to look at that as well. I'm going to go into the same format for this video, so a brief introduction to the rule, things you need to remember, basic example on how to find the length and the angle using the cosine rule, and then one question that's more worded or applied. Actually 3 for this video. So occasionally when you feel like you could do some part of the question or you want to try them, do pause the video and try. And do skip ahead to some parts that you think you already know. So again, just recalling why we use the cosine and the sine rule. We use them for any triangle. So it doesn't have to be a right angle triangle. We can only use the trigonometric ratios, the SOHCAHTOA, if you have a right angle triangle. In this case, we can use these for any triangle. They come in 2 forms, and these are given in your data booklet. So you have the form where you find the missing length. So you have a squared is equal to b squared plus c squared minus 2bc cos a. And then you have this rearranged such that you can find the angle. The labeling goes the same, where the vertices are labeled with capital letters, and then the opposite length is labeled with the lower case. So if you notice, it's always the opposite. So that's something you need to remember. Now, the tricky thing about the cosine rule is that you will have this labeling where a is your missing angle or length. But what if in the actual questions they don't have that? They don't have the A, B, and C labeling, or they actually have A, B, and C, but it's in an order that they picked. And for example, B is your missing length. What do you do in this case? Well, don't worry about the substitution. All you need to concern yourself with is the A letters here. And notice that this is a negative A squared. And the A will either be, if A is your given angle, then A will be your missing length. Just make sure you match these two in your formula. So if this is your missing length, then just look at, if this is my missing length, then this is the angle I have. Let's say it's 130. So you replace 130 in the missing angle. And then B and C could be in any order. This could be B, this could be C, or the other way around, doesn't matter. Because you are just adding them and multiplying them. It doesn't really matter if you change the order. And similarly in the other case, so this is for the first case, the second case, it's when A is your given length, then you need to match it with your missing angle. So this is where this is quite important, because your A will be negative. So you need to make sure which length are you subtracting. So if this is let's say this is the given length A, then I'm going to subtract this length. And then B and C again, doesn't matter which one you pick as B and C. And then the missing angle will be whatever is opposite to it. So this matching thing is really important when it comes to the cosine rule. It's also important in the sine rule, but it's not as complicated. So that's one thing to note. Another thing to note is that, remember, these are not in your final form. So once you found the answer to this, you have to remember to square root the answer, because this is, once you've substituted in the right-hand side, this is your A squared. And you want the value of A, so you'll have to square root whatever you got here. And similarly here, whatever you're going to get here, you're definitely going to get a value less than or equal to 1, most probably less than 1. So you'll have to take a cos inverse of this answer because you want the angle. So in the first case, you'll have to square it, and in the second case, you'll have to take the cos inverse. The reason we don't write the square root there and the cos inverse there is because the equation is going to look too complicated. In maths, we like to keep things in a nice, simple form. So I'd rather just keep the cos on this side and then remember to take the cos inverse at the end. Now, the last thing to keep in mind is, when do you actually use the cosine rule? We've mentioned this briefly in the sine rule, but it's not something that you'd obviously remember for the sine rule, but it's easy to remember with cosine. The first situation when you have this sandwiching situation, don't need to write it. So the sandwiching situation is when you have a length. So the green part is, you have this length, and then you have an angle sandwiched between them. So you also know this length. So 1, 2, 3. And the length you need to find is obviously will be the opposite to the length that you have. So because if this is C, then this has to be C, or if this is A, then this has to be so if this is A, then this has to be A. And this is the first case, the sandwiching situation. The other situation is when you have all three lengths together. There's no way you'd be able to use the sine rule because you need the angles. You need at least one angle, you need at least one angle in this case for the sine rule. But if you don't and you only have three lengths, then you should immediately think cosine rule. Now, so this is basically going through the basics of cosine rule, and now we're going to go through some basic questions. So we're meant to find x, very obviously. So in this case, you have all three lengths. So it's obvious that you'll have to use a cosine rule. So remember, I said if you have a missing length, a missing angle, then you match it with your missing length. And that's what you'll have to substitute in the formula. So I'm just going to write the formula down. Again, it's given in your data booklet, so you don't need to worry. So we have cos A is equal to b squared plus c squared minus a squared over 2bc. Now, so RA, and this is the formula as it is. Now I'm just going to do the substitution. Now it could have been labeled with A, B, C. It doesn't matter. Make sure that you don't confuse the labeling of the graph, of the diagram, with the labeling of the formula. The labeling of the formula has nothing to do with the graph. You just need to match the appropriate parts together. So in this case, our angle is labeled as x. It could have been labeled A, could have been labeled B, could have been labeled Q. In this case, it's x. Then I have the most important part I need to make sure is that I subtract the length opposite to my unknown angle. So x is my unknown angle. The length opposite to it is 86. So this is my minus a squared. So I subtract 86 squared. And then as I mentioned, everything else, the b and the c, will be these two. And it doesn't matter which one you pick as a, which one you pick as b, and which one you pick as c. They're interchangeable. So b squared could be 45 squared, and then plus 60 squared, and then 2 times 45 times 60. So it's important that you actually know you match the A's in this case, so the missing length and the missing angle. You can solve this as a numerator and denominator value, or you can put the whole thing in a calculator. However, you need to remember to put brackets at the bottom here when you're in a calculator, because if you don't, then your calculator will divide by 2 and then take the answer and multiply it by 45 and 60. So in this case, we get a negative 1,771 over a 5,400. Now, obviously, if I simplify this fraction, it's going to give me a negative answer, which doesn't make sense because you are dealing with angle. So obviously, we are missing another step, which is the cos inverse of this fraction. So negative 1,771 over 5,400, and that should give you let's round it to 2 decimal places. So this is the angle, 109.15. If you have time and you can spare this time, you can always try to find these other 2 angles and then make sure that all 3 angles add up to 360. That's a good way to practice. I would recommend you pause the video and try that now. It's just a good practice to go through using the cosine rule twice, and then just making sure that your answer is correct. So that's one way to find the missing angle. Now in this case, we have the missing length, and you can notice the sandwiching situation. Now they might give you another length here or so, but it's quite obvious that you'll have to use 1, 2, 3, these 3 lengths. So this question is actually find PQ. PQ as a length. So in this case, this will be our B and C. It doesn't matter which one. And this is our angle A, and this is our missing length. So just make sure this sandwich kind of matches with is opposite the length that you need. So we have A squared, or actually, yeah, we'll write the formula down and then just as it is in the data booklet. So minus 2BC cos A. And now we're going to actually substitute what we know. So PQ is the length that we need. And the cos A is actually 32. And then it doesn't matter which one is B, which one is C. We can just substitute in squared plus 6.3 squared. I've noticed a lot of students forget the squaring part. So make sure you don't lose marks on these tiny simple parts like substitution. And remember, there's no squaring in this part. It's only the beginning. So you plug this into the calculator. You can plug the whole thing. And I would recommend putting everything in there, remembering to square and remembering the costs and so on. I have seen students complete this part, the minus 2, and then they multiply the answer with cos 32, which is completely wrong because it's like you're multiplying with cos 32 3 times. There's also a case where students complete this, the minus the whole thing, and then they subtract cos 32 because of this subtract, this negative, which is not the case. So again, be careful with these situations. So this is 11.44, and this is PQ squared, remember. Now, this doesn't seem too bad. Maybe it is actually 11, but doesn't make quite much sense because 6 and 4 are quite small numbers. You wouldn't actually get 11 as a big distance, and sometimes it's more obvious with other numbers, but remember that you have to square root in this case because it wouldn't be 11. It's 3.38 kilometers. So 3.38 kilometers, and that is how you find the missing length. You could always use the sine rule actually to find any missing angles, and then try to use this value as well just to double check. So just be more comfortable with using other rules. Just as a practice session, you can pause the video and try it now to find the angle at P using the sine rule, and then decide if you could use the sine rule or cosine rule. You could use either to find Q, and try to use the 3.38 just to double check the answers, make sure the angles add up. So just try different things with these type of questions. So now that we've finished with the basics of finding missing angle, missing length, it's just the basics of substitution. A few worded problems. So I'm going to solve only one of these word problems. The others I'm going to leave on your own. So I'm just going to dissect the question for now. So you have a golfer played his tee shot at a distance of 220 meters to point A, and then he played 165 meters, 6 iron to the green. If the distance from tee to the green is 340, determine the number of degrees the golfer was offline with his tee shot. Now, if you don't play golf, this might seem like a lot of jargon. The 6 iron, the tee shot, and then offline with the tee shot. So it doesn't seem quite reasonable. And don't get too scared because there are some past paper questions that might actually, or future questions that might actually pop up with information that you don't actually know. You don't have to know everything. It would make sense with the diagram. So obviously, if you're trying to score as a golfer, you want to hit it straight to the green location or the flag. So he went a bit off from this shot. So they want to know how much off was he. And so the angle that they want is this. So he was off by that much. So he's meant to go straight, but he went off there. So this is the angle you need to look for. Now, noticing that you have 3 lengths, and you have a missing angle, so obviously you want to use the cosine rule. I will reveal the answer, not the solution, just the answer. So just make sure you pause the video, try it out, and then resume to see the answer. So the answer for this is 23.8975, and that's the 4 decimal places, degrees. So that's the length it is. Another question that I'm just gonna dissect and have you go through it. So a football goal is 5 meters wide. When a player is 26 meters from one goalpost and 23 meters from another, he shoots for goal. What is the angle of view of the goal that the player sees? So they've already told you where that is. It might seem a bit confusing that they're saying a football goal is 5 meters wide, so it might seem that this whole thing is 5 meters wide. But actually, if you try to recall, they're referring to this distance as being 5 meters. And so if we zoom into this even more, this will be your 5 meters. And then obviously the distance from this player to this post is the shortest distance, so this is your 23. And then from here to that post is the longer distance, so that's 26. Now it won't matter, and hopefully you can see why it won't matter, because these will be your B and C, so it doesn't really matter which one it is, but it's good to know from a diagram. Now there is a trick that they've actually given you a right angle here, and so they might give you a hint of, oh, do you actually need Pythagoras? Well, you don't really. It won't be useful because you don't have this length, nor do you have this length. So nothing about this right angle triangle will be useful. So it's just a misleading part of the diagram. But if you redraw the triangle, which is what I always recommend. So this is 23, 26, and 5. And this is the angle you need. So obviously now you have your 3 lengths, and this is your missing angle, and so you match it with your missing. So you have the situation where you have cos of this equals to your B and the C and minus the 5 squared. So remember, 5 matches with the angle. So do pause the video, continue with this, and I'm going to reveal the answer in a few seconds. So the answer to this is 9.38 degrees. This question I'm actually going to go through just one part of it and then leave you to do the other part. A parallelogram has sides of length 8 centimeters and 4.5 centimeters. One angle of the parallelogram is 124 degrees. Calculate the lengths of the 2 diagonals. A lot of wording in there that would be important for you to know. Let me try and get a parallelogram. Okay, so let's say this was our parallelogram, and this was our 8 centimeters, this was our 4.5 centimeters. And with a parallelogram, the opposite angles tend to be equal. Not tend to be, they have to be equal. And these 2 angles are equal. And you have 2 acute angles and you have 2 obtuse angles. So obviously the obtuse angle is 124. And therefore this is 124. And all the angles in a parallelogram, which is a quadrilateral, so it's a 4-sided shape, they all add up to 360. And so to find the length of the angle size of the other 2 is 360 minus 124 plus another 124. And that will give you 248. So the answer to the whole thing will be 112. But the 112 is this angle plus this angle, so you'll have to take 112 and divide it by 2, and that is going to give you 56. So the angle here is 56, the angle there is 56. Usually this type of filling in your construction is useful if you're ever confused about what to do in your diagram. Now, what they actually need is the length of, they want the length of this line, and they want the length of that line. And you could start with either, actually, now that we found all the angles there. So I'm just going to do one and then have you try the other length. But the most important part that you should have got to by now is the missing angles and filling them up. So for a parallelogram, you don't need anything else. So let's try to find the length of this diagonal. And I'm going to take this triangle out here. So it's going to be this is 8, this is 4.5, this is 124. So you do notice that we have a triangle, we have a non-right angle triangle, and we have this sandwiching situation. And so we are matching this angle with this length. So let's say this is the length A. And so A squared is equal to, well, B and C don't matter, remember? So 8 squared plus 4.5 squared minus 2, 8, 4.5 cos 124. And so you'll get that A squared is equal to A squared is equal to 124.511889. I've just written the whole thing. So obviously this is quite a long distance if it's 124, so you're missing the last step of square rooting the whole thing. So square root of the answer will give you 11.16. The units are centimeters, and that is to 2 decimal places. So we found this length as 11.16. And so the same exact method would be used for the other diagonal, but instead of taking 124, you take 56. So do practice this, and I'm going to reveal the answer. Just a point that I should make before you attempt this. Some of you might be tempted to go, well, if I draw the diagonal here, then this is 90 degrees. You might assume that this is 90 degrees. It isn't. And you can try to find the values, and you'll notice that this is not a 90 degree, and so you can't use a right angle triangle here. This will only be a 90 degree if the parallelogram was actually a rhombus. And a rhombus is a parallelogram where all the lengths are equal. So if they all had 8, for example, or they all had 4.5, they have to be equal, so that when you divide it into diagonals, this will be 90 degrees. So it's not the situation here. So be careful about any assumptions that you make when it comes to angle lengths or dividing a shape. So we only made sure that all the angles added up to 360 because we know that a 4-sided shape has angles adding up to 360, and knowing it's a parallelogram that the angles opposites will be the same. So the answer to the other diagonal hopefully you've attempted it, and the answer is going to be 6.63 centimeters. That's 2 decimal places. So hopefully the videos have been useful. I know they've been quite long, but the point is to go quite intense and in depth in these concepts.